Hello world. Today I'm going to show you how to create and access an SQLite database in an Android application using prepared statements when applicable. This video will show how to make the Java classes that perform database operations. In our SQLite database, we're going to have a transactions table with 3 attributes. We're going to have an ID that's going to be an integer that's going to serve as the primary key. We'll have a name, which is a string. Then we'll have money, which is a decimal. We're going to create a Java class that holds the values for these 3 attributes, a long, a string, and a double. But then we're going to create a more robust gateway class that will perform various transactions on the database: create, read, write, update, and delete. Let's begin. Start by opening up Android Studio and create a new project. Give your project a name. Here we're calling this one Prepared Statement. Give your project an SDK, click on Next. Select a blank activity, and then click on Next. For this example, we can just leave the activity name, the default, and click on Finish. Right-click on the package, and select New Package. Name the new package DBO. Then right-click on the new DBO package. Select New Java Class, and we'll call this class Transaction. Create 3 private variables in your transaction class, the ID, name, and money. And then type Alt-Insert and select Getter and Setter. Select all the variable names and click on OK. And then once again, right-click on the base package for your project. Select New Package and call this new package Gateway and click OK. Right-click on the Gateway package. Select New Java Class. Give the class the name Gateway and click on OK. Import the needed libraries into this class to access and control the database. Also import the transaction class that we just created. And we'll also need to import an array list class for returning multiple results. Make sure the class extends SQLite Open Helper. You'll see a red squiggly line here because we need to implement a few methods in order for this to be syntactically correct. And we'll get to that. But right now, create some private static variables that'll be used to hold descriptions of the database, the version, the name, also the name of the table, and the various attributes in that table. Notice for our variable table transaction, we're giving it the string value transactions. The reason why is because in the singular tense, the word transaction is an SQLite keyword. Create a constructor that receives the context and an SQLite database cursor factory as arguments. Most of the time, whenever this is instantiated, you're going to pass null for the second argument. But if there's ever a reason when you need to have a customized cursor for the data that you receive from the database, this is where you would pass it. And inside of the constructor, call the superclasses constructor, passes the context, the database name, the factory, and the database version. Now create a method to create the new database. You'll have a string builder that serves as the database query, and here you'll just create the transactions table and define the attributes for it. We're not taking any user input here, so prepared statements aren't necessary at this point. Then create an onUpgrade method that receives the database, the old version, and the new version as arguments. Execute a drop tables if exists statement, and then call the onCreate method that we just defined. Now define a delete method. This is going to need a primary key for the argument, so we're passing it along. Instantiate an SQLite database object with a getWritable database method, and we'll execute an SQL statement that says delete from transactions where the column ID is equal to the ID that was passed. And here, since the only user input we're putting in is a number, prepared statements aren't necessary for this because none of the meta characters that could be used for SQL injection are numbers. Once the statement's executed, then we close the database connection. Then create a save transaction method that will receive one of our transaction objects. This method is going to perform 2 different functions, depending on the context. If the transaction that's passed to this method has an ID, and if that record already exists in the database, then it's going to perform an update. Otherwise, it's going to perform an insert statement on the database. So instantiate an SQLite database object with getWritable database. Create a cursor variable. Also create an array list that takes objects, and then create a string variable we'll call simple query result. Create an if statement, checking to see if there's an ID that's defined in the transaction object, and then define the base of our SQL select statement. This is going to be the statement that checks if the record already exists. Tell the database to begin the transaction, compile the statement to be an SQLite prepared statement, and then bind the transaction ID to the SQL statement, and then execute the SQL transaction, set the transaction to successful, and end the transaction. Now create an if statement to check if the record already exists and if the ID is defined. Then we'll begin a transaction non-exclusive with our database object, and we'll define our update query with a new string builder. And then one by one, we're going to create the set portion of our SQL query. Start with the ID. If the ID is not equal to null, then we're going to check if there are objects in the array list. If there are no objects, we add the word set to our statement. Otherwise, we need to add a comma. And then we'll append the transaction column ID with a question mark as a placeholder for the ID. And then we're going to add the ID to our object array list. And we'll do the same thing with the transaction name and also with the transaction money. And then, of course, we need to specify which record needs to be updated based on the transaction ID. And then we need to compile our prepared statement. And then we need to set the individual objects that we pass to that array into the prepared statement. So we're just going to loop through each and every single one of those objects and check the data type of each of the objects. And then we will bind each of the objects to the statement according to its data type. And finally, we execute the update statement. Then we set our transaction to successful and end the transaction. And then outside of the if statement, define an else statement. If we get to this point in our program, the record does not exist, and we need to perform an insert transaction. Now our SQLite database object, it's able to define its own prepared insert statement out of the box. So what we do is we create a contents values object, add the name and the money from the transaction, not the ID, because for our database table, the ID is an auto increment. It'll define itself. Begin the transaction non-exclusive. Tell the database to insert the content values, set the transaction to successful, and end the transaction. And finally, we will close the database connection. Then define a method to get the transaction by its ID. And this time, we'll instantiate our SQLite database object with the getReadableDatabase method, define the transaction object, and instantiate it. Then also define our select statement. This is a simple select statement pulling only one record by its ID, and the data type of the ID is a long, so SQL injection should not be possible with this. So we're just hard coding the ID variable straight into the query. Now, one of the frustrating things about dealing with the SQLite database object in this case is that there's not a way at the time this video was made to create a prepared statement, execute it, and then get the resulting rows that you would get from executing the statement. So the prepared statement works well for updates and inserts and deletes, but when you actually need records from the database, there just doesn't seem to be any options available right now. So then we execute the query and define a cursor to iterate over the results, which in this case there should only be one. Move the cursor to the first position. And then we're going to define a while loop to get the SQL transaction results. Now in theory, the SQL query should only return one result, but this loop is created just in case there are no transaction records with a given ID, and it doesn't try to set a bunch of null data that could potentially throw some errors. And so we use our cursor just to get the column index of each of the columns from the table and set it into our transaction object. And make sure you do this at the bottom of your while statement. Call the move to next method for your cursor. Otherwise, your while loop will become an infinite loop. And then return the transaction record that you got. Now define a method to get all the transactions from the database. Create an array list that takes transaction objects. Instantiate your SQLite database object with the getReadableDatabase method. And then build the SQL query and execute it. In this case, it's just going to be select everything from the transaction table. And then move our cursor to the first position. And then, much like before, create a transaction object and set the name, money, and ID attributes for that transaction based on the contents of the cursor. Always make sure you call the move to next method for your cursor, and then add the transaction object to your array list. Outside of the while loop, close the database connection, and then return the array list of transaction records. And now we're going to define a method that will allow us to search the database based on the value of specific attributes using the Boolean operators, such as AND or OR. We'll pass two arguments to this method: a transaction object that contains attributes that we want to search for, and also a string that represents the Boolean operator that's going to be used for the logic of the search. Then create an array list of transactions, an instantiated SQLite database with getWriteablesDatabase method, and then start building the SQL query, and then define two string builders, one for the select portion of the statement, and another to hold the where clause that's going to be added to the end of the statement. Cycle through each of the attributes that are in the transaction object. If the transaction object passed to the method has an ID, check if the attribute count is greater than 0. If it is, then we just need to add our Boolean operator, which will be either AND or OR. And then we'll append a statement saying ID equals the ID that's in the transaction. And once again, we're returning results, so we've got to have a cursor. And thankfully there doesn't seem to be any way to do SQL injection using only numbers, so we just pass the ID straight into the query. And also make sure we increment our attribute count. And then we do the same thing for the name attribute of the transaction. Now here, it is possible to do SQL injection when searching for a string value. The best solution I have right now is to get the string value of the name and then perform a replace all function on single quotes, because in this statement the string is going to be sandwiched between two single quotes, and any SQL injection that's going to be possible is going to be done by terminating the statement with a single quote. So we need to escape that out. And also do the same thing with the money attribute. However, money also being a number, it doesn't seem like there's any way to do SQL injection here. Now append the where clause to the SQL query if there were attributes that were passed into the transaction object. So if all the values of the transaction otherwise. Then we close the SQL statement with a semicolon and we execute the query, get a cursor, and move it to the first position. And then loop through each of the results in the cursor, and for each of the rows that were returned from the database we'll create a new transaction object. It will appropriately set the ID, name, and money attributes of our new transaction object. Inside of our loop, move the cursor to the next and add the transaction object to our array list. And then outside the loop, close the database connection and then return the transactions array list. And now, just to make things a little easier for ourselves later, we're going to define a wrapper method that calls that previous getTransactionList method we just created, and we're always going to pass the second argument and to it. So that way, all we have to do is call this method and pass a transaction object with the attributes that we want to search. Now this will be an exclusive search, meaning that the search results are going to be narrowed for each of the attributes that we add. So if we search for a name and we also search for a money amount, it's going to have to match up with both. Otherwise the record won't return. And now also do the same thing with the Boolean OR operator. And this will be used for inclusive searching. So if you pass a name and a money amount to a transaction to be searched, if either the name or the money amount is true, then the record is going to be returned. This is a much broader search than using the AND operator. And that's all there is to this portion of the tutorial. I hope this is helpful. Thank you.